recording. Okay. So part 7 is optional for you. So here part 7 is talking about when spreadsheets fail. This is just to bring in that why we are using the database packages, or you can say DBMS, database management system. Because we know that we can record the data in spreadsheets, or you can say in Excel sheet. We can easily record the data, and we use that to record the data. But there are certain things that makes it difficult to use this data in due to some drawbacks, due to some problems with the spreadsheets. So those problems are discussed here in part 7. It is optional part for you, but still we'll just have a look into this, that what are the problems related to the spreadsheets, and that's why we are going to use a DBMS, database management systems, or database packages. We're not going to use the spreadsheets. Okay. So can you guess what can be the problems in this case in using spreadsheets? If we want to record a data, for example, a supermarket data or an hospital data, can we use the Excel sheets? And if we use the Excel sheets, what can be the problems with the Excel sheets? Any idea what can be the problems? Yes, Firas. There is a big data, so we need more space. Good. Okay, when the data becomes big, it will be more difficult to maintain in the Excel sheets. Yes. What can be other problems? Salman Zuhair, can you mention some problems? Can you guess? Firas. Firas Abdul. Ibrahim Saad. Are you hearing me? Are you getting my voice? Yes, I can hear you now. Your voice is very low.
ما في صوت يا دكتور.
دكتور المرة ما في مشكلة، ما بنسمعك.
دكتور ما في فويس، نو فويس.
دكتور ما في صوت.
Okay, can you hear me now?
Yes, we can, Doctor.
Now it's clear, huh?
Yes.
Thank you very much. Can you see the screen? Okay, fine. So I'm just talking about these problems with the spreadsheet failing to management analysis concern, where we talk about this control, right? Controlling the spreadsheets, that is in the sense controlling the data. And then the sharing of the data, legality of the data, privacy, protection, backup and recovery, and all this, right? Now, we talk about this control of the data that what is the problem in the spreadsheet in terms of controlling the data. So in controlling the data, we all know that spreadsheets can easily be shared, right? We can send the sheets or Excel sheet to one user to another user, right? So there is no control over the data. And data can become corrupted or deleted by someone, okay? For example, we send the data to one user, he made some mistakes, by mistake, he deleted some data, he sent to another user, he found that data is not available, some data is missing, okay? Also, in controlling the data, we may come up with many versions of these spreadsheets, like version 1 having some data to keep that a backup of it, then version 2 another backup, version 3 another backup, right? So it's the controlling is not easy here while we record the data in the spreadsheets, right? Also, it relates to the security, we'll say access to the data. Data can be accessed by many users, right? So how do you know that the users who are accessing data are authorized users? Because once anyone gets the link to the file, or once anyone gets the file, he can do anything with that file, right? So how do you control it that the access to the data is only given to the authorized users? Also the privacy data, how you going to protect the data from the accidental disclosure or from unauthorized access? Okay. Also there is issue with the integrity and the audit. So these are some control issues related with the spreadsheet. Similarly, with the sharing of the data, we can easily share the spreadsheets. Fine, we can send, for example, we can upload it in a cloud, on a cloud, or on a share folder, and just give the link to other users. They can access it online, do the entries online. Okay, but at the same time, while doing this, some may overwrite some others data, right? And while we share the data, someone can easily copy the data, can save the local files in their computer, right? So sharing is also a problem. What is the legality of the data, right? Because you're sharing with many users, you might feel that, okay, there can be a chance that some data is not legal, or there can be a chance that some data has been copied illegally, right? So also the privacy of the data, as we talk about it, fine. Protection, how do you ensure that the data is protected, right? Backup and recovery of the data in the event of corruption or loss. Okay, so do you have the backup of this spreadsheet? Fine. If you have that backup, it will not get the current data. You will get only the old data, what has been recorded and backed up. Fine. So for example, you have every week backup. So every week backup, it means, for example, you get only the last week data if your file of this week is been corrupted. So this week data is all gone. For example, let's say that you back up on every Thursday, at the end of the Thursday. So end of the Thursday, then this week we already on Wednesday, we recorded 4 days data, and tomorrow the file is gone corrupted. So all these 4 data you will be losing. So you'll only have the data of the last week. So this can be a backup problem, data curation problem. So current concurrency or currency and maintenance of the, these are all some flexibilities, again a problem here, right? So spreadsheets were never meant to handle the large amount of data. Okay, small amount of data, it's okay, we can handle with the spreadsheet, but large amount of data. Nowadays, you see every organization, every company is producing large amount of data. Even you take the supermarkets, they are producing large amount of data of sales and purchase and customers. Okay, you take hypermarkets, they are producing large amount of data. You take universities, they are producing large amount of data of students and faculties and events and so on. For any company you take, they are producing large amount of data. So for this large amount of data, spreadsheets were not enough or not good to use to record the data, right? Because of the performance issue, and even they become slow and they may be more unstable, right, while using the data. So this is why it is marked that spreadsheets are not the best for managing the large amount of data. Fine. So that's why we see what we see here as data management system, database management system, which is DBMS. Right. So here from part 8 to part 12, you'll be discussing, or we will be discussing, database management system and its related things. Fine. So completely from 8 to 12, 4 parts are very important here. Like we saw the part 2 to part 5, that is data analysis pipeline, was important for us from part 2 to part 5. So now the next important thing here in the course is from part 8 to part 12, which is about database and database management system and relational database. Okay. And also NoSQL database that we will discuss in part 12. So now we'll talk about the database or DBMS. Fine. So during this, you will be following with the teaching material for part 8 to 12 will be the selected chapters from online book, which is by the author Pulraj Punnaya, Database Design and Development by Pulraj Punnaya. You can also have this parts of this book from the CLMS. Fine. I think I have those parts of this book by Pulraj Punnaya. Punnaya books, chapter 1, 7, 8, 10, 12, 13, 15. Yeah, chapter 13. Yeah, I do have this chapters of Punnaya, which we will be discussing here. Okay. 8, 10, 12, 13, 15. So you try to download it from here. If you're not getting, I will send you that. Okay. I do have the chapters from here. So the reference for you for this part 8 to 12 is from the book called Database Design and Development, an essential guide for IT professionals by Pulraj Punnaya. Okay, so we'll be discussing the topics from this book and these chapters of the book. So what we will be studying in this part? So in this part, we'll be discussing about database management system. You will be introduced to database management system. Fine. In general, we'll talk about relational database. Fine. And the part is divided into 3 sections: database and DBMS. This will describe how database system overcome the inadequacies of file-oriented system to manage and analyze the data. And then we'll talk about relational database. This will introduce a relational data model. And then movie data set, which introduce some data as movie data set, okay, for practical activities. Right. So to start with database and DBMS, where here we talk about the advantage, or we can say the features or the applications of DBMS, database management system. Right. So here the core functions of DBMS, as given here as summary, that the DBMS, database management system, fine, enables the data to be shared in a controlled manner that maintain the security and the integrity of the data. DBMS, I repeat this, the core function provided by DBMS that enable data to share in a controlled manner that maintain the security and integrity of the data. So what are those core functions? It is data definition. So we have a provision of defining the data. So provision of data definition, it is by using a data definition language to define the data in the database and the relationship between the data and the constraint on the data. This is the whole what we call it as a database schema. So we can define a database schema where we can define the data in the database, what will be the data. We can create a relationship between the data, and we can also set the constraints on the data. Fine. So it will be more clear for you when you use an SQL as for a data definition. Okay. So here to define the data in the database, in the sense to create the data in the data sets. That is, you create the data structure there, the structure of the whole data. Fine. That is, for example, if you talk about student data. So what will be the student data in the database? What do you record the student data? You may record a student first name, a student last name, student ID number, a student email, mobile number, and so on. So how do you record it? And you may also record, for example, course data, course code, course name, credit hours, number of points, or course course price, right? Then creating a relationship between these data, like for example, a student and a course. So a student register a course. So how do you create a relationship between a student and a course, right? And then also, for example, if you take the example of patient and a doctor, so you create a data of patient. So what you will include in this patient, you may include in the patient data that patient ID, patient name, patient age, for example, patient contact number. Similarly, you record the doctor data, doctor ID, doctor name, doctor contact, specialty, or something like that. Then you create a relationship between the doctor and the patient, right? And then you can also set the constraints on the data. Constraints on the data, for example, let's say that the student age should be greater than 18 years. Or you can say this, the date of birth of a student should be greater than the current date, okay? Or you can say in the patient, the date of birth of the patient should be greater than the current date or today's date, fine? So these are constraints. Constraints are nothing but rules that you set on the data. So you can define that in the DBM. One of the function of DBMS is to define the data, that is data definition. Another function of the DBMS is to manipulate the data, that is data manipulation. So provision of data manipulation language to manipulate the data in the database. So you can create the data, you can retrieve the data, you can update the data, or you can delete the data. So it is also called as a CRUD operation. That is create, retrieve, update, and delete. Fine. It's also called CRUD operation. So here you can create the data, you can insert the data. For example, you want to insert the patient data, patient P01, name Ahmed, age 25, contact number 05412336, and so on, right? You can update the data. For example, you want to change the mobile number of patient P01, you can change it, okay? You can delete the data. For example, you want to delete some records, some patient records, some student records from the student database, you can delete the data. So these all provisions are given by the DBMS through data manipulation, right? So you'll better understand this while you're doing this data manipulation using SQL language. Then it also gave a provision of constraint enforcement. You can enforce the constraint rules on the data. That, for example, the student ID should be S, starting with S, then it should be 3 numbers. So you can fix this, that every student ID will be in this format, starting with S and then 3 numbers. That will be a constraint. Then access control. Similarly, you can enforce many different constraints, okay? Then access control. You can define the user rights to access the data. And you can also prevent the users from accessing the data. For example, if you we'll talk about SIS. So SIS has all the student data, but when you log in, you access only your data, right? When I log in, I can access only my data as well as the student's data, but I cannot access, I don't have an access to the financial things, I don't have an access to other things, right? Academic things, I have an access in the database. So that's what access control, that you have a provisions like to give what users what access, right? That is an access control. Through DBMS, we also have a transaction support. Okay, so transaction is nothing but when something has been done, okay, an update in the database or any operation on the database, fine. is nothing but a transaction. Fine. So transaction support, like we need to make sure that the whole transaction will work completely or fail completely. The classical example for this is, for example, if you are transferring amount from one bank account to another bank account. Let's say that you want to transfer amount of 500 real from your account to your friend account. So when you make a transfer, this should be deducted from your account 500 real, and this 500 real to be added to your friend account. Okay, so this is one transaction. So when this also reflect in the database, in the bank database. So when you make a transfer, first thing is that it has been deducted from your account. Then the second thing is this, it has been added to your friend account. So this should be one complete transaction. What happens, for example, when you make this transaction, amount is deducted from your account, but there was some network problem, some problem happened, then the transaction is stopped, the application is stopped, you cannot continue the application. So now you are already deducted 500 real and it is not added to your friend. So where does this 500 real will go now? So in this case, the transaction is not complete, right? So DBMS will take care of it, that if the transaction is not complete, it will just reverse the transaction and keep back, return back 500 real back to your account will be added. Okay, it is just roll back. We call it as a rollback, right? So 500 will not be added to your friend account. So transaction support will help in this matter of whether the whole transaction will complete successfully or it will fail without changing the state of the database. Right? Also, it may support, the DBMS will support concurrency of transaction. It means more than one user is performing the transactions, so at the same time. So how to support this, that in such a way that the database will always be in an updated state, or it will be consistent state. So concurrency support is again also database recovery is another function of DBMS. So restoring a database to a usable state in the event of data loss or corruption due to hardware or software failure. So these are the functions of DBMS. So this is why we are going to use DBMS. So these are all the core functions provided by DBMS, which will help in enabling the data to be shared in a controlled manner and that maintain the security and the integrity of the data. Right. So you can see that most of the problems of data, the spreadsheets, are solved here. So there is no problem of backups. There is no problem of concurrency. There is no problem of access control. There is no problem of how do you manage the data, the transaction support. Fine. So this is all the core functions of the DBMS. Now the second part will be relational database. Relational database, you will be learning that how the data will be organized in a form of tables, okay, and how the relations will be created between the tables. I mean, sorry, how the relations are created between the tables. And how do you relate one table with another table? For example, we have a patient data and we have a doctor data. So how do you connect these two data, that which doctor is treating which patient, right? So in that way, we'll have this relational database. So relational database will help us to learn about the database, which is in the form of tables and relation between the tables. We do have some exercise on it. Movies dataset we'll be using here just to practice the activities of relational database. Now, I just wanted to take you, I just want you to, just have some activities to be explained here that will help us to gain more on this. Shortcomings of file-oriented database. We already file-oriented system. We did discuss this. Benefits of database management system. We just discussed the benefits of database management system. We'll just recall this: minimal data redundancy. There will not be duplication of the data if you are using database systems, okay, to manage the data, meaning that there will not be replicated data, or there will not be repeated data. Fine. So as the data is consolidated and is stored in one place, that is in the database, data duplication can be more easily controlled in a database systems that reduces the data redundancy. This is the benefit of employing the data into database systems. Integration of data is possible here, okay, that we can integrate all the related data together. Preservation of data integrity and consistency through the functions of data definition, constraint enforcement, transaction support, concurrency support, we can preserve the data integrity and consistency. It is another benefit of having database system. Data sharing is possible here, that we can give an access control functions, we can apply and give access to the users and what they based on their priorities, based on their role in accessing the data. We have transaction support, we have concurrency support. Easy with uniform standard to be established, can be established. We can have a uniform data, fine, for all the data, when uniform structure for all the data. Better enforcement of security controls. We can enforce the security controls, reduce program maintenance through data independence, and simpler backup and recovery. So these are some benefits of having data in a database system, okay, than having the data in a file-oriented system. So in the chapters of Punaya, it is also described how different type of database are used to support data management analysis requirement of an enterprise. Right. So operational database support, it help in data operations, and it is data management, that we record the data of day-to-day operations. Right. So here the data is recorded as a raw data in a structured way. Fine. And decision support database provide a support for making decisions in the organization. Fine. So for that we'll be using for operational online transaction processing, which is OLTP systems, and for decision making we may using online analytical processing systems. Okay. Now here, this figure, we're talking about this figure 8.1 and 8.2. This is showing the data of doctors and its patient. Okay, and here is the patients and their doctors. So data is arranged. Either it can be arranged in a list of doctors and their patient, or we can also say that this is just a list of doctors and their patient, and here list of patients and they're currently assigned to each patient. The doctors currently assigned to each patient, right? So how we can record this data when we are talking about if you want to record this data in a database in a form of tables, right? So it's very simple that we can record the data, for example, a patient data in a patient table with the details of patient, like patient ID, for example, patient name. We have two things here, patient ID and name. So this is the James is the name, ID is P008. So we can record the patient ID and patient name here, fine. And for doctors, we have two things, doctor ID and doctor name. That is D07 is ID and passed on is name. So we can also record it here. But to create a relationship between this patient and a doctor, we can say that which doctor is seeing which patient based on this record. That okay, that Thornton P001 is seen by Dr. Gibson. So what is the ID of Gibson? D06. So what we do is that we record a doctor ID here who is seeing this patient. So that will be copied here for Gibson. D06 will be copied here to ensure that this patient is seen by this doctor currently. So we create two relations here. One is a patient relation with patient data. Another is a doctor relation with a doctor data. And we create a relationship between these two by including a doctor ID in the patient table. So with this, it creates a relationship between the patient and the doctor, where we can easily say that this particular patient is seen by particular doctor. So first, for example, P008 James is seen by Dr. D7. So who is D7? You can look here. D7 is passed on. Similarly, P009 is seen by Dr. D06. So who is D06? D06 is Gibson. Fine. So this way, it's creating a relationship between these two tables, that doctor and a patient relation. Fine. So in this way, it becomes a relational database. Fine, where we have the tables, patient and the doctor, and the relationship between with these two. And when we copy this doctor ID over here, then we call this as a foreign key, because it is coming from another table. So we call here doctor ID is a foreign key in patient relation or in patient table. So using foreign keys, we create the relationship between the patient and the doctor, or between two tables. Fine. So that's what it is explained here. The represent of information is shown in figures as two relations, named patient and doctor, showing the relationship between data as represented through foreign keys. That is, through the foreign keys. So here the foreign key is doctor ID. So what are the basic relational properties? That is the properties of the tables or the relations. Fine. So it said describe the properties of relation. How do these properties differ from those other tabular forms of the data, such as spreadsheets? And what are the implications on the data content of relation and how it is accessed? So what is the basic properties of relations, or nothing but tables? So what can be the basic properties is that the properties of relation makes them unique among other tabular forms such as spreadsheet. And what are those properties? Row uniqueness, okay, or unique identifiers. So every row is identified by some unique ID. Okay, so each row is unique here, that there is no duplicate rows. Fine. So here every row is unique in the sense there is some unique ID. For example, if you talk about patient ID is unique. So by the patient ID, every row is unique, right? Even the name comes the same. Might be two patients have the same name, but their ID is different. So in that sense, their their rows are unique here. Fine. So we have a row uniqueness, and we also have the order of rows. The order of rows does not matter here. You can arrange the rows in different orders, but it will remain the same data. The data will remain the same. Right. So this is two properties of the relation that makes different from other forms of data, that is such as spreadsheets. So when we have a unique rows, fine. So we can use the primary keys, the unique properties we can use as a primary key for that table. So in the sense, for example, in this relation or in this table, we have patient ID as unique. So we can say patient ID is a primary key of this table. Using this primary key, we can access the records. And similarly, for doctor, we can say doctor ID is a primary key. Similarly, for a student, we can say student ID is a primary key because it is unique to every student. So we can say unique primary key. Fine. So it is not only one property or one attribute will be unique. We can combine different attributes to make it come also unique. Fine. So that is called a primary key. Fine. Now, in a relational model, each attribute takes its value from the same domain. So what is a domain and how does it differ from primitive data type provided by other programming languages? So we need to understand here what is a domain. So a domain is nothing but it's a set of atomic values of the same data type. Okay, that will be taken by the attributes of the table. So for example, let's say that we want the patient ID to be starting with P and 3 digits from 000 to 999. So in that case, we are creating a domain of patient IDs, that is the pack of patient IDs, that every patient will take the patient ID in this format, P then it will be a digit, another digit, another digit, 3 numbers. Okay, it can be P001, P002, P003, like this. So you cannot have a patient with S123 because it should start with P. So that is what we call it as a domain here. Fine. So domains are similar to user-defined data types in programming languages. Okay. Fine. Concept of null in a relational database. So in a relational data model, what is the function of null and what are the limitations of null with respect to semantics of data? So null is used when the value might be not available at present, okay, or value is missing. Fine, absence of value. So null in relational database, null is a marker indicating absence of value, okay, that is of a column or a row, okay, of a relation. Then also, or absence of relationship between the tables can be used. For example, if you're using a foreign key value as null, it means absence of relationship between these two tables. Fine. For example, there is a patient record, but no doctor has seen this patient. So for this patient, doctor ID will be null. Okay, for example, let's say that in this relation, we create here another patient, P100, Muhammad, and here we say null. Doctor ID is null. Why? Because this patient is created but not seen by any doctor. Okay, so here we see that P008. We can see P008 Jarvis null. So what does it mean? It means this patient is not seen by any doctor. So there is no relationship for this record with the doctor relation. Fine. Also here you can see null. Fine. So null, either some value is missing, fine, absence of value, or absence of relationship between the tables. Or absence of value can be raised because of value is not known or not available or not applicable. Sometimes value is not applicable. In that case also, we can use a null marker. So it is just a marker. It's not a value. It is just a marker. And we can use this null marker in our transactions. Right? We want to know what are the patients not seen by any doctor. So you can say select all patients where doctor ID is null from the patient relation. So we can use that. Okay, now what are the weaknesses? Can we talk about the weaknesses of relational database? So we can talk about these weaknesses of relational database, that when we have a relational database and it is a normalized relation, we'll get more tables. Okay, so for example, you look at this bill, fine, it has an ID of a user, order ID, customer name, we have a customer details here, then we have item details, their price, then we have a payment details. So if you want to put this in a relational database, you will put it in 4 different tables. So as the data increases here, okay, so independent data is recorded, fine, in different tables and create a relationship between the tables. This increases the complexity of maintaining the data, right? So, or keeping the data in more tables, fine. So more tables are created here. So that's one of the weakness of DBMS, fine. Okay, so this this is all about the part 8 what we have here for you, as in just an introduction to DBMS, the functions of DBMS, and a relational database system. Fine. So this you are clear about what is a relational database system and what is DBMS, what are the core functions of DBMS. Fine. This should be clear to you. Fine. Do you have any questions? Part 9 and 10 are the most important. Yeah, you take it from part 8 to 12 are important, right? Part 8 you just have the features of for the functions of the DBMS and the features of relational database and why we need relational database. Okay, this is what you have. And inshallah, part 9 will start with the relational database.
Doctor,
Yes.
if I didn't attend with you right now, it's okay. I can have the grade of the attendance, or it's necessary to attend with you all the class.
How do you get attendance when you are not attending with me?
How?
I mean, how do you get the attendance if you are not attending with me in the class?
No, I attend with you, but if I have excuse.
You want to excuse?
Yes.
Okay, do you have anything or?
Yes.
Okay. Fine, no problem, inshallah. It's just for today.
Okay.
Okay, no problem,
Okay.
inshallah.
Thank you.
You're welcome. Fine. Do you have any questions related to this approach, DBMS and relational database, that what we discussed, primary key, foreign key? No questions? Okay, I'll stop the recording here just to separate this with part 9. And we will take part 9, inshallah. Okay.